Welcome to Get Your FRQ On. This question is from 2011. It's question 1, and it is calculator active. In the question stem, we have a particle moving along the x-axis. Its position function x of t is not provided, but the function for its velocity and acceleration are provided, and we are given that the position of the particle at t equals 0 is equal to 2. In part A of the question, we are asked if the speed of the particle is increasing or decreasing at t equals 5.5 seconds and to provide a reason. Well, the speed of the particle, whether it's increasing or decreasing, is dependent on the signs of v of t and a of t at t equals 5.5. So we need to determine the values of v of 5.5 and a of 5.5. Right, it's a calculator active question, and it would be very difficult to determine the correct values for v of 5.5 and a of 5.5 given what the functions are. They're not very nice, they're transcendental. Use your calculator to do these. When we use our calculator, we find that v of 5.5 is negative 0.4533, and a of 5.5 is negative 1.3585. Now, since both velocity and acceleration are negative at t equals 5.5, their quotient is positive, which means at t equals 5.5, the speed of the particle is increasing. In part B of the question, we are asked to find the average velocity of the particle between t equals 0 and t equals 6 seconds. Now, by definition, the average velocity of this particle would be the average value of our velocity function between t equals 0 and t equals 6 seconds. We are provided with the velocity function, so we have an average value problem here. That would be given to us by the value of the integral from 0 to 6 of v of t dt multiplied by 1/6. So we need 1/6 the integral from 0 to 6 of 2 times the sine of e to the t over 4 plus 1. Again, this is a calculator active question. We're not going to do this by hand. So use your calculator, and we get an integral value or an average value of 1.949 after we multiply by the 1/6. In part C, we are asked to determine the total distance traveled between t equals 0 and t equals 6. This is a slightly different integral for the definition. The definition of total distance traveled requires us to integrate the absolute value of our velocity function. So the total distance traveled is the integral from 0 to 6 of the absolute value of v of t dt, which would be 1/6 of the integral from 0 to 6 of the absolute value of 2 times the sine of e to the t over 4 plus 1 dt. Again, it's calculator active. We're going to use our calculator to do this. It turns out that that integral has a value of 12.573. In part D of the question, we are asked for what values of t between 0 and 6, the position when the particle changes direction. All right, so this is actually a two-part question. We have to determine when the particle changes direction, which is one calculus problem. Then we have to find the position of the particle at that time, which is a different calculus question. So the first part, we have to determine when the particle changes direction. The particle is going to change direction when the velocity function v of t is equal to 0, but also changes sign. All right, so v of t equals 0. We can solve this equation algebraically, kind of. So we get v of t equals 0, 2 times the sine of e to the t over 4 plus 1 equals 0. So that would have to equal negative 1/2. But again, it's a calculator question. Use your calculator. T equals 5.19552. And one thing I do want to point out here is this value of t that we're going to be using, we're not done with it. We're going to have our calculator do some more calculus with this value. So note the additional precision here. Typically, you'd want a final answer in a free response question to be correct to 3 decimal places. But we're not done with this, and if we round it too soon, the answer we get later might actually be off in at least 1 decimal place, and that would cause us not to earn a point. So use a little bit of extra precision here on this value of t, but we do need to find the position at that time t equals 5.19552. This is a fundamental theorem of calculus problem. The position at 5.19552 is going to be the location, or the position at x equals 0 plus the integral from 0 to 5.19552 of v of t dt, which is going to be 2 plus that integral. But since we have our graphing calculators, where it's a calculator active question, we can use a calculator to calculate what that is, and it turns out it's 14.135.